Hi there, Rachel Sherman here, and in this video we're going to take a look at the quotient remainder theorem as well as the divides and mod functions. The quotient remainder theorem tells us that if you have an integer n and a positive integer d, there exists some unique integers q and r such that n is equal to dq plus r, and note that r is bound between 0 and must be smaller than d. So if you think about what all of these things represent for a moment, you've got d for your divisor, q for your quotient, and r for your remainder, and is of course whatever number you're looking at. So why is it that r is required to be smaller than d? Because of course if r was equal to d, that would mean that you could divide in one additional time. So think about how you would use the quotient remainder theorem to set up the following. So for example, n is equal to 60, d is equal to 7. So we would say that 60 is equal to 7 times some integer, this is our quotient, plus whatever the remainder is. Well, how many times does 7 go into 60 whole? And then figure out what your remainder is from there. Since we know that 7 times 8 would give us 56, that's the closest we're able to get to 60 without going over, and then our remainder would be 4. And this is something you could also set up using long division. It's just a different way of showing how the quotient remainder theorem works. This does also work with negative integer values. So for example here, if you have negative 27, and then we have a divisor of 9, that would be 9 times a quotient of negative 3 with a remainder of 0. Now, using this idea, we can also look at both the divide and mod functions. The divide function is saying that you are taking whatever integer value is left, regardless of if there's a remainder or not. The mod function is only instead looking at the remainder. For those of you who are familiar with programming, typically you see these written in your programming. The divides function would just be n/d, and you would use the percent symbol for mod. So if you have n% d, you might have used this previously in something. So if we were to take a look at 22 divide 7, that's how many times does 7 go in whole, which would be 3. The remainder is irrelevant in a case like this. So the divide function is taking only the integer value. It's essentially truncating whatever that outcome would be. On the other hand, if you have 22 mod 7, you only care about what the remainder would be. Well, 22 divided by 7 is 3, goes up to 21, and then you have a remainder of 1. So we would say that this is, and typically use congruence here, that would be congruent to 1. The mod function also works with negatives. These ones are a little trickier though. The tip that I have for you is when you start with a negative value for your mod, keep adding whatever the divisor is until you get back up to something that is between 0 and whatever the mod is. What do I mean by that? So for this one, it's pretty small numbers, but I would start with negative 5, add 2. That only brings us to negative 3. I'm going to add another 2, since this is what we're modding by. Negative 1, add another 2. I'm just going to bring this up here. And you'll notice that this gets us just over that bump. So it's the first value that gets us back to the positives. So this would be 1. If you had this on a larger scale, you could definitely still do it. You may want to just play around a little bit with your calculator to find whatever's quickest and easiest. But the mod function, remember, is dealing with the remainder, and it's always going to be a number that's between 0 up to but not including this number here. So something that's mod 2, the only outcomes could be 0 and 1. If it said mod 7, it could be anything from 0 through 6. If it was mod 100, anything between 0 and 99. That concludes this video. Thanks for watching.